Hello.
Hello.
Hi Diksha Didi. Good afternoon.
Good afternoon.
Today we are gonna continue with passing arrays to a function where we left in the last class.
Okay.
So here it is. C++ pass array to a function. So pass arrays as function parameters. So we can also as we saw we can pass by reference. We saw the basic features of functions like returning values, passing by reference, we passing multiple parameters, having a default parameter, etc. Right? Similarly, we can also pass arrays to a function. So over here we have our my numbers array, which is having 5 elements, and we are passing this array to my function. In my function we are accepting an array, right, an integer array that will contain integers with 5 elements, right, and we are looping. Basically we are just looping on the array we received, and showing each element of the array, right. So this is a basic code. Over here we are just creating an array, we are passing it to the function is accepting it and looping on it. So the function my function takes an array as its parameter, right, and loops through the array's elements with the for loop. So it will loop through the array using the for loop. So when the function is called inside main, we pass along my numbers array, which outputs the array elements. Very simple method. So note that when you call the function, you only need to use the name of the array when passing it as an argument. So when passing it as an argument, you only have to use the name. You don't have to specify the data type or how many elements the array has, right? However, the full declaration of the array is needed in the function parameter. So in the parameter, the full information of the array is needed, that which data type elements will be there in the array, and what is the max length of the array. So this was how you can pass arrays. So is this clear?
Yeah, it's clear.
Alright. So next we are on function overloading. So I've created an example for function overloading also. So let's just see over here. So with function overloading, multiple functions can have the same name with different parameters. So you can have multiple functions with the same name but with different parameters. So like you have a my function that will return an integer value that is accepting integer x. Then you have a float function that is returning a float value, that is taking a float value, right? So it will return a float value and also take in a float value. And then you have my function that has the double value. The return value will be double type, and it's taking in double data types value, right? So as you can see, we have my function, all the three places we have the same name, my function, but we have integer return type, float return type, and double return type. And we have integer x, we are taking in integer x in the first function, float x in the second function, and double in the third function, right? So this is overloading. So we'll just see an example of it. Consider the following example, have two functions that add numbers of different data types. So we have a plus function integer that will take in two integers and add both the values, and we have plus function double that will take in two double values and return the addition of those values. So we are using these two functions separately now. So instead of defining two functions that should do the same thing, it is better to overload one. So it's better to overload one. So in the example below, we overload the plus function to work for both integer and double. So what we have the plus function that is taking in two integers and returning the sum of the two integers, and we have the same plus function that is taking in two double values. So whenever double values will be given to the plus function, this function will be called. Whenever integer values will be given to the plus function, this method will be called. So this is overloading when having the same name but with different parameters, so that different function definition for the same functions are used. So is this clear?
Okay. Yeah, it's clear.
Alright, so we have one more example over here, but with namespaces. So what do we have over here? We have our own namespace in which we have print text, right? And we are just printing inside, right? And we have our print text that is taking in two integers and it will show outside. So what will happen now? We are saying using namespace A. So the behavior is like it is this print text is available globally. So now whenever we call print text without any parameters, this namespace print text will be called. But whenever we call it with parameters, with two when we give it two arguments like 0 and 1, then print text that is outside will be called, as the print text that is outside is taken in two arguments and that is inside is taking no arguments. So when we give it two arguments, then it this is also an example of function overloading with namespaces. So when we give it parameters,
Okay.
it detects that this the printx method having two parameters should be called, as we are giving it two parameters, but two arguments, sorry. And when we don't give it any arguments, it sees that if it receives any arguments, no, it does not receive any arguments. So it will basically see that the inside method does not need any arguments, so it will call that method. So it will call the namespace method in this case. So it's calling inside, right?
Yeah.
So this is function overloading, where one same method can do multiple tasks. And now we have the concept of recursion. So have you done recursion before in Python?
No, I don't think so.
All right. So this may be a bit complicated right now. So let's just focus on this a bit. So recursion is the technique of making a function call itself. So now, when you should I delete this code? Uh,
Yeah, sure.
all right. So for example, I create an function. I'll just comment this. I create integer x, right? So it's returning an integer value, for example, and we are gonna say no parameters, right? Now recursion is when a function call itself. So in x we are calling x itself, right? So in the x function we are calling x itself. This is recursion, right? But now you can see over here, this is never ending, because when it goes in x it will call x, then it will go in x, it will call x. So this will lead to an infinite loop kind of, right? Because in x we are calling x again and again. There's no terminating thing, right? There's no terminating aspect of the function. In x we are again and again calling x, right? And this x call will never end, right? So we have to there's a technique to use recursion. So this technique provides a way to break complicated problems down into simple problems which are easier to solve. So recursion may be a bit difficult to understand. The best way to figure out how it works is to experiment with it, right? So in recursion, let's just start with an example so that it's more clear. So adding two numbers together is easy to do, but adding a range of numbers is more complicated. In the following example, recursion is used to add a range of numbers together by breaking it down into simple tasks of adding two numbers, right? So let's just copy this code, because we won't be able to understand it with just text. So over here we have the sum function and we have the main function. So what this sum function will do, it will take in a number, and like for example I pass it 10, then it will add it will do 0 plus 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. If I give it 5, it will do 0 plus 1 plus 2 plus 3 plus 4 plus 5, right? So this is the aim of the sum function, to add a range of numbers. So now let's see how it works. We have integer k, right? So we are taking in 10 uh, in and taking saving it in k. We're checking if k is greater than 0. So right now 10 is greater than 0, then we'll return k plus some k minus 1. So we are returning, I'll just comment over here, we are returning k, that is 10, plus some k minus 1. So we have k minus 1 is 9, so sum 9. So now when sum 9 is called, it checks if 9 is greater than 0. Yes, 9 is greater than 0. Then it comes over here, it returns k, that is 9, plus sum k minus 1, that is 8, right? Then it calls sum 8, it goes over here, it checks if 8 is greater than 0. Yes, 8 is greater than 0, so it will go in here, it will return k, that is 8, so plus 8 plus sum k minus 1, that is sum 7, right? Next, if we when sum 7 is called, it checks if 7 is greater than 0. Yes, so it returns 7 plus sum 6, right? Then when sum 6 is called, it returns 6 plus sum 5. Then once so on it goes on. Let's just fast forward to sum 1, plus 4 plus 3 plus 2 and plus sum 1, right? So when it reaches to 3, it checks if 3 is greater than 0. Yes, so it returns 3 plus sum k minus 1, that is sum 2. Then when it checks for 2, 2 is greater than 0, so it returns 2 plus sum k minus 1, that is sum 1. So now when sum 1 is called, it goes in, it checks if k is greater than 0. So 1 is greater than 0, so it will return 1. So it is gonna return 1 plus sum k minus 1, that is sum 0. And now when sum 0 is called, it will go in, it will check if 0 is greater than 0. No, 0 is not greater than 0. Then it will go in the else statement and it will return 0. So over here we'll get 0. And the final output, when we started from 10, in till the end we get 10 plus 9 plus 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1 plus 0. And this will be our result that will be returned from the sum method, and then it is gonna be saved in the result variable. When we show the value of result, then we'll get the value of the range, that is over here 55. So if this is this clear, or it is a difficult concept, I can re-explain it once.
I just need to read it once again.
uh,
Give me a minute.
yeah. So over here we have a terminating statement, that is in else return 0. If we never terminated it, it would have called sum again and again, again and again, and infinitely had called, it would have called sum. So
Okay, it's
uh,
clear.
it's clear.
Yeah.
All right. There's also one more thing we can do with this. I'll just give you as homework. So you can also give you use recursion to show the Fibonacci series. So have you heard about the Fibonacci series?
Yeah, I've done it.
So you have so in the next class, you can just show me how you are using recursion for printing the Fibonacci series.
Okay.
All right. So that will be a short exercise that will make the concept more clear. And don't worry if you're not able to do it. That's fine. We'll just do it in class once also.
Okay.
Alright, so here's a simple explanation. So when the sum function is called, it adds parameter k to the sum of all numbers smaller than k and returns the result. When k becomes 0, the function just returns 0. When running the program, follow these steps. So 10 plus sum 9, then 10 plus 9 plus sum 8, then we are 10 plus 9 plus 8 plus sum 7, and so on till sum 0. Then when it reaches to sum 0, it returns 0, and we had this final output. So since the function does not call itself when k is 0, the program stops there and returns the result. Right? So the developer should be careful with recursion, as it can be quite easy to slip into writing a function which never terminates. or one that uses excess amounts of memory or processor power. However, when written correctly, recursion can be very efficient and mathematically elegant approach to programming, right? So this was recursion, uh, pretty cool concept. Say. Now we are on OOP, that is Object Oriented Program. OOP stands for Object Oriented Programming. So Python is also an object oriented language, right? And basically, what object oriented programming is, you everything in OOP, object oriented programming, is an object. Like you have a variable of type string, so that's an object, right? So it has methods like you can take out the size of your string, you can work with the string, you have integer, you can add two integers, so everything in OOP is considered as an object, right? So procedural programming is another type of programming. It is about writing procedures of functions, so it's based on functions that perform operations on the data, while object oriented programming is about creating objects that contain both data and functions. So right, so object oriented programming makes your life a lot easier, right? And most people these days are using object oriented programming only. So object-oriented programming has several advantages over procedural programming, right? So that is that OOP is faster and easier to execute. It's very faster than procedural programming. It provides a clear structure for the programs, so you exactly know what is happening. Like if you have a car object, you know that this will possess the properties of car. If you have like a jar object, you know that it will possess the properties of your jar, whatever properties a jar has, right? So you will know what is happening in your programs, right? It will be pretty clear. OOP helps to keep the C++ code dry. That means don't repeat yourself. You won't have to repeat much of your code. For example, you want to create a car object, you can just create a class of it, right? And then you can create objects from that class instead of again and again giving properties to your car, to different cars, right? So if you have Toyota and Volvo, two cars, you can just create a car class from which you can create your object, instead of again and again defining what properties Volvo possesses, what properties Toyota possesses, etc. Right? And makes the code easier to maintain, modify, and debug. Right? So OOP makes it possible to create full reusable applications with less code and shorter development time. So it makes it possible to create full reusable applications with less code and shorter development time. So the don't repeat yourself dry principle is about reducing the repetition of code, right? So it's about reducing the repetition of code, it's reducing the rewriting of code, right? So you should extract out the codes that are common for the application and place them at a single place and reuse them instead of repeating it, right? So this you should follow this principle, don't repeat yourself, so that you won't have to repeat the code again and again, and your application is much more efficient. So till now is the advantages of OOP clear? I think Python is also an object-oriented programming language.
Yeah,
Programming,
it's clear.
yeah. So have you done classes in Python?
Could you give an example?
Like you could create class in Python and then you could create an object in Python, like using the class keyword.
I'm I'm not sure. I don't think so though.
Alright, so this will be a new concept. Let's just take it as a new concept. So, classes and objects are two main aspects of object oriented programming. So, you have a class from which you will create objects, like you have a string class from which you create strings, you have an integer class from which you create integers, right? All these data types are essentially classes from which you can create objects. Like every variable is kind of an object of a data type. Like this int result, this is an object of our integer class, you can say, right? So over here, like you have a fruit class, you can define a fruit class with basic properties like its sweet, its shape, right? And then you can create objects from the fruit class, like an apple is an object, a banana is an object, a mango is an object, Like similarly, you have like an integer class from which you are creating integer variables in which you are saving values, right? Similarly, like that, like you have a car class from which you create Volvo, Audi, Toyota, right? So we are gonna see this in working in the next chapters, but basically you can create classes and then reuse those classes codes to create multiple objects, as many objects you want, right? So you can create as many objects as you want from one single class. So a class is a template for objects. You can take it as a template for objects. Like you have a cookie cutter, for example. So from that cookie cutter, you can create multiple cookies, right? Like similarly, if you have a car class, you can create multiple car objects from the car class. So a class is a template for objects, and an object is an instance of a class. So it's an instance of a class. An object is an instance of a class. So when the individual objects are created, they inherit all the variables and functions from the class. So from this text, it may not be clear how it's happening, but when we see the example, it will be very much clear. So you'll learn much more about classes and objects in the next chapter. So let's just dive into it. So classes and objects. C++ is an oriented programming language. We know that. Everything in C++ is associated with classes and objects along with its attributes and methods. For example, in real life, a car is an object, right? So a car is an object. The car has attributes such as weight and color and methods such as drive and brake, right? And
Yeah.
attributes and methods are basically variables and functions. So attributes are variables and methods are functions. So these are attributes and methods are just a different name for variables and functions, but we use them when we have variables and functions that belong to a class. So when we have weight and color variables that are in the class, then we call them attributes. When we have functions like drive and brake in our class, then we call them methods. All right. So these are often referred to as class members. All of these together are referred to as class members. So a class is a user defined data type that we can use in our program. So a class is very similar to structures. A structures you can call is a subset of classes, right? It's structures that we learned are smaller classes, you can say, right? And it's a you can
Okay.
create your own data type using classes, like you have string, bool, integer. Similarly, you can create your own data types, and it works as an object constructor or a blueprint for creating objects. So it can work like an object constructor. Like an object constructor allows you to create an object. Similarly, classes will also create you allow you to create objects, right? Now, creating a class. We can create a class using the class keyword. So we can say, should I delete the recursion code?
Yeah, sure.
Alright. So we can create a class using the class keyword, like class, and we can say my class, for example, right? Then we can give brackets. Now public. We'll understand public, private, protected in a later chapter and in brief also. And then we'll have attributes like integer, my num. So that's an attribute. And you have string, my string. So these are attributes of our class. So this is a very basic class that we have created over here. So what is happening now? I can use my class as a data type. So I can say my class, right? And I can say first like object is equals to. So I we'll see how to yeah. So we can say my class object. So now object is an instance of my class, and now we can set the value of its properties like my num. So we can say object dot my num is equals to 10, and object dot my string is equals to hello. So let's just understand this in a second. First, let's just recall structures. In structures also, we created objects and gave its properties. a value, right? So in structures, let's just go back to structures to just recall. So in structures also, in named structures, so when we had name structures, we created an object and then it gave values to its properties. Very similar thing we are doing over here with classes. We are creating a class, right? And we'll just see public, that is an access specifier that I'll tell you in a second. And basically we have basic properties, right? Whose values we are giving after creating an object or an instance of a class. So what is happening over here? Here we are creating a my class. Now public. Public is an access specifier. What do we mean by an access specifier? Uh, Access specifier tells which properties or attributes and methods should be accessible, right? So how the properties and methods should be accessible. Like we have mynum and mystring that we are giving under public. This means that we can access mynum and mystring, so we should be able to access mynum and mystring in the class itself and also outside the class, right? So over here we are accessing mynum and mystring outside the class because the access specifier uh, tells us that the properties that are under it should be publicly accessible. They should be accessible in the class and outside the class both times. Then we have protected. We also have a protected access specifier, so that it's like protected. This won't allow you to access your attributes outside your class, right? But what it will allow you to access your attributes inside attributes and methods. When I'm referring to attributes, I'm talking about both attributes and method. So protected will allow you to refer to your attributes and methods or only in your class and in the inherited class. So inherited class we are gonna see. So if we have class my class 2, so we can tell C++ that my class 2 will possess all the properties and methods of my class and will have separate properties and methods of itself too. So protected will allow us to access these two attributes and method its attributes and methods in the class itself and in the inherited class. And finally we have the private access specifier, and that tells us that we can only access these attributes and methods that we give under private in the class itself. We cannot access it in inherited class, we cannot access it in outside your class, we can only access it inside your class. So this was a brief overview on access specifiers that we are gonna see later. We have a full chapter to about it also, access specifiers, in which we are gonna see about these in detail. So is this much clear?
Okay. Yeah, it's clear.
The access specifier also.
Yeah, it's clear.
Alright. So here we created a well, let's just revert this to public. So here we have just a basic class. The class keyword is used to create the class called my class. The public keyword is an access specifier which specifies that members of the class are accessible from outside the class. You'll learn more about access specifiers later, alright? Inside the class there is an integer variable mynum and a string variable mystring. When variables are declared within a class, they are called attributes, right? And at last in the class definition with a semicolon. So we have to end the class definition with a semicolon. Now we are on creating an object. In C++, an object is created from a class. So as we are seeing over here, we are creating an object from our my class, right? We have already created the class name my class, so now we can use this to create objects. We can instead of one object we can create 100 objects, like object 1, object 2, and we can name our objects anything like any other variable, right? We can say name our objects anything we want. So to create an object of my class, specify the class name followed by the object name. So to access the class attributes mynum and mystring, we'll use the dot syntax that was in structures also. So to access mynum, we are saying object object dot my num is equals to 10, and we are saying object dot my string is equals to hello, right? So we will use the dot syntax to access its attributes and methods. So let's just see over here, they are created they have created a my object, so they name their object my object, right? And they're just giving values to the attributes, that is my num 15 and my string, they're saying some text. Now what we can do, we can use these values anywhere we want. We can like print the values like object dot my num, for example, and it will show us the value that is 10. We can say object dot my string, and it will show us the value, right? Hello. So this is how you can create objects. You can also have multiple objects, as I told you earlier. So you can create multiple objects of one class. So now we have a more practical class, that is our car class. It's a more practical example of classes. So every car will have a brand, a model, and an year, right? So now we can create objects of the car and give the each car its brand, model, and year. So we created a car object one, whose brand is BMW, model is X5, and year is 1999. We also created object 2, in which we had brand Ford, model Mustang, and year 1969. So we can just copy this code and paste it over here. So just right, so we have BMW X5 1999, because we are first showing car object 1 dot brand, its model and year. Then we are saying we are showing object 2 dot brand, object 2 dot model, and object 2 dot year, right? So we can create as many objects as we want, as I told you earlier. And then we have the classes. Very cool. Next, we have methods. Till now, we were only creating attributes. Now we can create methods also. Methods are functions that belongs to the class. So there are two ways of define functions that belong to a class: inside the class definition or outside the class definition. So we can create them inside the class definition or outside the class definition. There are two ways. So in the following example, we define a function inside the class and we name it my method. Note, you can access methods just like you access attributes by creating an object of the class and by using the dot syntax. So you use the dot syntax to access methods of a class also. And there are two ways how you can create methods of a class. First, you are creating it inside the class. So this is the inside example that we'll just copy over here. So we have my class, in which we have a public access specifier that will tell us that we can use everything that is in under publicly. So we have my method, right, in under public. So this is a public method, right, and we are creating it like any other function like we create outside a class. So we have given the return type void, as we don't want to return anything. We named the method, we gave parentheses. If we had any parameters, we could have specified over here in between the parentheses, and then we have the braces to open the method definition, and then we are just printing hello world in this method. Now we can create an instance of this class and run my method using the dot syntax. So we are saying my object dot my method, and we are just giving parentheses to call it, because parentheses are important, as we are trying to call the function. So when we say my object dot my method, we call my method, and it will basically just show hello world. We are getting hello world. And
Okay.
to define the function outside the class definition, you have to declare it inside the class and then define it outside of the class. So to define it outside, you have to declare it in here. So you can just give it the definition that we have void my method. So this is telling that this class has a my method, right? But now, we also need to give it a body so that when we run it, it does some work. So we can say void, we can say my class, my method, right? And what this is saying, this over here is saying that our my class is my method, we are giving it a body over here outside, right? And we can just say out hello world. So we defined it inside, but we are giving it a body outside, that is that will just the body will just show hello world. And now when we call my method, it will work exactly the same. So you're getting hello world. Is it clear?
Okay. Yeah, it's clear.
All right. Now, like any other functions, we can also give parameters to your class methods. Like you have a car a class over here. In that, we are creating a public method speed that will return an integer value, right? And it is taking in a max speed, right? And what we are doing, we are saying we are not given a body over here, right? So this is our outside example, we can call it the outside example, right? And we can outside, we are giving it a definition, we're saying int, and we are saying car. So car, we are telling that the car class is speed method, we are giving it a definition, and we also have to specify the parameter that we gave in here, right? And in this method we're just returning the max speed. So whenever we get the parameter, we are just returning that value. So if I give 100, so it will return 100. If we give 200, it will return 200. If you give any integer, it will just return that integer, right? And what we have created an instance of our car class, and then we are just calling it speed method, right? And passing it 200. So then it will return us the value 200, and we are just printing it using out. So very basic example of parameters, how to accept parameters in a class methods. So we have this example that we just copy pasted, and we have 200, right? So we get 200. If we pass like 500, we get 500, right? So very basic. So we have till now seen how to create classes using the class keyword. We have seen how to give it attributes, how to work with the attributes. We have seen about access specifiers, we have seen the methods, right? And we have seen how to give parameters to those methods, right? And we have the next topic, constructors. Now the class is about to end, so we'll continue with constructors in the next class, that is tomorrow. So
Okay.
uh, that recursion code, I think we you will do, and we'll just see it tomorrow, right? And you can share the screen.
Sure. Sure, done.
Yeah. All right. Thank you.
Thank you.
Bye.
Bye.